Have you ever examined whether we are truly the only ones in the universe? On the other hand, are you accepting that there's more to our existence than meets the eye? Instead of what we see, imagine what would happen if the James Webb Telescope finally demonstrates that we live in a black hole that has the potential to alter everything. As we find out more about this revolutionary discovery, it will make you question everything you believe to be true about the universe. So what exactly are black holes? They look like something from a terrifying nightmare. You may have seen them in sci-fi movies, but in actuality, they're truly terrifying. Researchers claim that black holes exist in space and contain an immense amount of material packed into an extremely small area, like a star, usually much bigger than the sun, compressed into a sphere the size of New York City. The gravitational pull is so strong that not even light can escape. Scientists have been fascinated by black holes for a long time. They have studied objects in space that are so massive and dense that they can shed light on the most well-known theories. Black holes were first predicted by Einstein's general relativity theory. Essentially, when a massive star collapses, it leaves behind a dense core. If the mass of this core is several times that of the sun, gravity takes over entirely, resulting in the formation of a black hole. Detecting black holes is no simple endeavor because they do not produce light. However, researchers have discovered methods to infer their presence by observing their effects on nearby objects. For example, if a black hole moves through a cloud of matter from other stars, it will pull that matter toward it through a procedure known as accretion. Additionally, when a normal star gets too close to a black hole, it can be torn apart, emitting X-rays in the process. Consequently, black holes also possess a significant impact on their surroundings. They can consume nearby stars, emit powerful radiation, and even influence the occasional emergence of new stars. But where exactly do black holes originate? Imagine stars, once enormous and powerful, ending their lives violently in a spectacular event known as a supernova. From the remnants of these fallen giants, the majority of black holes emerge. Massive stars that reach the end of their life cycle explode in a supernova, while smaller stars become neutron stars, extremely dense, but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under the weight of its own gravity, forming a black hole. Strange things occur during these collapses. Near their surfaces, time itself begins to behave differently. From the perspective of a distant observer, time appears to slow down near the event horizon, the final destination for anything that falls into a black hole. It's as if the star's clock ticks at a different speed compared to our own. Sometimes, when two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, the result is a huge cosmic phenomenon beyond comprehension. Scientists have been trying to comprehend the scale of these gigantic mysteries for decades. Black holes come in two main sizes, large and small. Despite the fact that small is a relative term, stellar mass black holes, remnants of giant stars, can be anywhere from 10 to 100 times the mass of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. But wait, there's something even more extraordinary. At the extreme end of the spectrum, there are enormous supermassive black holes. These behemoths are millions, if not billions, of times the Sun's mass. They inhabit the centers of massive galaxies, including the Milky Way, acting like monstrous dead zones pulling everything toward them. Stephen Hawking, a well-known physicist, studied black holes extensively throughout his life. His discussions were always intriguing, but a few of his theories couldn't be confirmed due to a lack of the necessary tools. However, there is hope on the horizon. A single scientific instrument is making a huge difference: the James Webb Space Telescope, JWST. Let me tell you, the JWST is no typical telescope. It is an engineering marvel, a testament to human ingenuity. Sure, we've launched other space telescopes before, and they've served us well, but this powerhouse is truly amazing. The JWST makes the Hubble Space Telescope, useful to us for decades, seem like a distant memory. The cost of this astronomical wonder? A staggering $10 billion. Yes, you read that right. This miracle of science was brought to life through the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, with invaluable contributions from over 300 colleges and universities. However, such an ambitious project comes with significant risks. The JWST is venturing into uncharted territory, pushing the limits of what we know and taking us to places we've only dreamed of. Recently, after a successful launch, NASA announced that the telescope has enough fuel to last more than twice its initial mission lifespan. Since its launch, the JWST has accomplished some incredible feats. It traveled over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. Throughout its journey, the telescope successfully deployed its massive 5-layer sun shield and giant primary mirror, both of which had to be folded to fit inside the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is nearly ready for full operation. One of the most breathtaking moments of the JWST's mission was when NASA announced the first images it captured of starlight. The first image taken by the telescope was of a star called HD 8446, producing an 18-piece mosaic of scattered stars with bright spots of light captured by the 18 mirror segments. Later, NASA released another stunning image of HD 8446, where the 18 out-of-focus copies of the star were arranged into a deliberate hexagonal pattern. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the process of stacking images, integrating all 18 images into a single clear view. Thanks to its state-of-the-art technology, the JWST will help scientists study the universe's earliest stages. It will focus on what happened after the first stars formed during a period known as the epoch of reionization, when neutral hydrogen was reionized due to radiation from these first stars. This involves looking back billions of years, something only a powerful telescope like the JWST can achieve. The telescope will also aid in discovering exoplanets, which are incredibly difficult to detect due to their interaction with their host stars. Its potent sensors will have the ability to examine these planets more closely, sometimes even analyzing their atmospheres. Understanding the conditions of these planets could help scientists determine whether or not some may be habitable. In addition to studying planetary formation, researchers are using the JWST to analyze galaxies and understand how they are structured on a massive scale. This, in turn, helps us recognize how the universe evolved and how the twisting, bending galaxies we see today formed over billions of years. One of the goals is to look back at the earliest galaxies to better understand their development. But the most notable aspect of the James Webb Space Telescope, it may help us answer the biggest questions of all. The detection of polycyclic aromatic hydrocarbons, PAHs, around supermassive black holes is groundbreaking. These molecules are not just cosmic dust. They're complex organic compounds that play a crucial role in the chemistry of space. Some scientists even speculate that they could be linked to the origins of life. If PAHs exist in regions near black holes, what does that mean for the possibility of life elsewhere in the universe? For decades, astronomers have searched for signs of extraterrestrial life, primarily by looking for habitable exoplanets. But now the focus is expanding. Instead of just searching for planets in the Goldilocks zone, where conditions are just right for liquid water, scientists are also studying how complex organic molecules survive and evolve in extreme cosmic environments. Could black holes be gateways to other universes? As we continue to unravel the mysteries of black holes, an even more astonishing possibility emerges. Some physicists theorize that black holes could be gateways to other universes. This concept, rooted in quantum mechanics and general relativity, suggests that instead of being just destructive voids, black holes might connect different parts of space-time, or even lead to parallel universes. One mind-blowing theory is that our universe itself may have originated from a black hole inside another universe. If this is true, it challenges everything we thought we knew about cosmology. The JWST's ability to observe the earliest galaxies and study the structure of black holes might provide crucial evidence to support or refute these theories. The future of space exploration with JWST. The James Webb Space Telescope is just getting started. As it continues to scan the depths of space, scientists expect even more discoveries that could reshape our understanding of the universe. Some of the most anticipated missions include searching for signs of extraterrestrial life by analyzing the atmospheres of distant exoplanets, studying the birth and death of stars to understand how galaxies evolve over time, exploring the mysterious dark matter and dark energy that make up most of the universe but remain largely unknown. What if we are not alone? If JWST finds definitive proof of extraterrestrial life, whether in the form of microbial life on an exoplanet or complex organic molecules in space, it will be the most significant discovery in human history. It would force us to rethink our place in the cosmos, our origins, and even our future. Could intelligent civilizations exist elsewhere in the universe? Are they watching us, just as we are searching for them? These questions, once confined to science fiction, are now at the forefront of modern astronomy. Conclusion. The James Webb Space Telescope is not just a scientific instrument. It is a time machine, a cosmic detective, and a portal to the unknown. Every image it captures, every molecule it detects, and every galaxy it maps brings us closer to answering the fundamental questions of existence. Are we truly alone in the universe? Are black holes more than just voids of destruction? Could we one day find evidence that changes everything we believe about reality? As JWST continues its mission, one thing is certain. The universe still has its secrets left to reveal, and we are just beginning to uncover them. Typically an indicator that hot, young stars are close by, but the twist will come later. Ismael Garcia Burnett, an inquisitive astrophysicist from Oxford University, made the decision to examine 3 active galaxies: NGC 6552, NGC 7319, and the well-known Stephan's Quintet, located millions of light-years away in the depths of space. What Garcia Burnett found will make you feel like crying. In the central regions where black holes rule, he found an abundance of PAHs, polycyclic aromatic hydrocarbons. Sounds interesting, right? Now comes the eerie part. The radiation close to those enormous black holes distorted the PAHs, essentially transforming them into larger, neutral to electricity versions of themselves. The smaller, electrically charged PAHs vanished into the darkness, almost as if they were swallowed whole by the void itself. But wait, there's a glimmer of hope, or perhaps not. The actual question is not simply whether or not we are alive, but whether we truly exist. Does everything around us exist because of the black hole we're in? Everything seems to align with the theory that perhaps we are not simply residing within a black hole, but rather within its event horizon, a boundary between the universe we know and the unknown. Could it be that everything is connected within a black hole? The James Webb Space Telescope is out there right now, searching for answers to these mysteries. Stay tuned. Maybe it will make us all rethink everything we believed we knew about existence. Reality might be far more twisted than we ever realized. The mystery of black holes. Few topics in cosmology generate as much mystery and fascination as black holes. These colossal entities, with their ability to warp space-time and consume everything in their immediate vicinity, have been the subject of both scientific study and popular imagination. The recent claim made by Michio Kaku, a well-known physicist, that we have finally discovered what's inside a black hole adds even more intrigue to the discussion. But what does this bold statement mean? Has science finally unlocked the secrets of what lies beyond the event horizon of a black hole? Understanding black holes. To grasp Kaku's assertion, we need to step back and understand what black holes are. A black hole is a region in space where gravity is so strong that not even light can escape. This phenomenon occurs when a massive star collapses under its own weight after running out of nuclear fuel. When this happens, the star's core contracts, and if the mass is great enough, it forms a singularity, a point of infinite density where the laws of physics as we know them disintegrate. This singularity is surrounded by the event horizon, the boundary beyond which nothing can escape, not even light. For a long time, black holes were purely theoretical. The concept first emerged from Albert Einstein's general theory of relativity, but it wasn't until the 1960s and 1970s that scientists like John Wheeler, Roger Penrose, and Stephen Hawking developed the mathematical structure that introduced black holes into mainstream science. Even with this theoretical understanding, black holes remain shrouded in mystery. What lies beyond the event horizon? The event horizon of a black hole represents a point of no return. Once something crosses this line, it is inevitably drawn toward the singularity, where it is reduced to infinite density. By the nature of black holes, we cannot directly observe what lies beyond the event horizon. Light cannot escape. For a long time, scientists believed that black holes were cosmic prisons, where all information regarding the objects that fell into them was lost forever. This idea led to the information paradox, which arose from Stephen Hawking's work in the 1970s. Hawking proposed that black holes could slowly evaporate due to what is called Hawking radiation, a quantum effect suggesting that black holes gradually lose mass over time. If this radiation carried away all information about what had fallen into the black hole, it would violate a fundamental principle of quantum mechanics, unitarity, which states that information must always be preserved. New developments in black hole research continue to raise questions and challenge our understanding of the universe. Are black holes gateways to other realities? One particularly intriguing concept is that black holes could be gateways to other parts of the universe, or even other dimensions. This idea forms the basis of wormhole theory, which suggests that black holes might act as tunnels that connect different parts of space-time. Although wormholes have not been proven to exist, they are frequently depicted in science fiction as shortcuts across the universe. If such exotic structures were real, they could potentially provide a way to bypass vast cosmic distances, offering us a glimpse into an entirely different reality. Do we live inside a black hole? Black holes have also sparked discussions about the very nature of reality itself. Could it be possible that the universe we see is merely a simulation, part of the event horizon of a massive black hole? Some scientists and philosophers suggest that our existence may be tied to the enigmatic forces that govern black holes. These questions force us to reevaluate the fundamental principles of physics and the role of consciousness in shaping our perception of the universe. Could we be confined within a black hole, living inside a distorted space-time that alters our very perception of reality? Black holes and the nature of time. Additionally, black holes may provide insights into the nature of time itself. Close to the event horizon, time slows down relative to an observer farther away. This phenomenon, known as time dilation, could hold the key to understanding whether time is a constant or something that can be manipulated by the forces at play in the universe. Future research into black holes may uncover new technologies or theories that allow us to manipulate time, or even explore what lies beyond. The final cosmic mystery. At the end of the day, black holes remain one of the most puzzling mysteries known to humanity. The James Webb Space Telescope, with its modern technology, might play a crucial role in uncovering their deepest secrets. As we continue to investigate the farthest reaches of space, the mysteries of black holes will only expand, captivating our imaginations and driving scientific discovery.